Traffic shaping decides which agent work gets capacity. Concurrency control decides which jobs may act at the same time without corrupting shared business state. An agent fleet can admit the right work and still create collisions. Two agents refund the same order. One updates a CRM record while another overwrites it with stale data. A retry acquires an abandoned lock. Parallel workflows reserve the same inventory or send conflicting customer messages. If concurrency control is weak, more workers can make the system less reliable. Race conditions create duplicate side effects, lost updates, inconsistent decisions, stuck resources, and business outcomes that are difficult to reconstruct after the fact. This is more than idempotency. Idempotency prevents the same request from producing the same side effect twice. Concurrency control coordinates different requests that touch the same resource, invariant, or limited pool at the same time. After MCP connects tools, permissions control actions, memory gives context, evals test behavior, observability traces production, human handoff routes risk, governance owns the fleet, security protects boundaries, cost control limits spend, reliability handles failures, release management ships changes safely, incident response contains outages, scaling handles demand, data quality keeps facts trustworthy, ROI proves value, adoption builds daily use, the operating model ranks the portfolio. The platform gives teams safe build paths, compliance evidence proves controls ran, privacy keeps sensitive data under control, data residency controls where data goes, vendor risk controls who the agent depends on, vendor continuity proves provider failure is survivable, model routing chooses the right model, context routing chooses the right knowledge, action routing chooses the safe action mode, workflow state tracks the live run, workflow orchestration moves the work, exception handling controls failed runs, transaction safety controls commits, outcome reconciliation proves business truth, service levels define the promise, and traffic shaping allocates scarce capacity. The next layer is concurrency control. Build it in 5 parts. First, map shared resources and invariants. Identify orders, accounts, cases, inventory, budgets, approval slots, and external systems that cannot accept conflicting changes. Second, define concurrency keys. Use a stable business key such as order ID, customer ID, case ID, tenant, campaign, or provider account. Keep the scope narrow enough for throughput and broad enough to protect the invariant. Third, choose the control. Use optimistic version checks for low contention, a mutex or serial queue for exclusive updates, leases for recoverable ownership, and semaphores for limited shared capacity. Fourth, manage contention. Set wait deadlines, bounded retries, priority rules, clear rejection reasons, and human handoff for work that cannot safely wait. Never let retries create a lock storm. Fifth, recover safely. Expire leases, detect orphaned locks, reread current state before writing, reconcile partial outcomes, and record who owned the resource at every decision. That is the AI agent concurrency control autopilot. Map shared resources, define concurrency keys, choose the control, manage contention, and recover safely.